Welcome to DTH channel. In today's session, we will discuss about 8051 microcontroller. So, the microcontroller is the basic one which is used to design the embedded system. Every one of us came to know that embedded system. Embedded system is a simple application which is used to develop for the specific design with a low cost, because within the system we have all kind of applications which we have the basic processor, input device, output device, memory with the supporting of serial and timer counters. Okay. So, based on that, every one of us before starting the design we have to know what are the internal structure of the controller. So, for that in today's session we will discuss about the 8051 architecture. The 8051 is a 8-bit microcontroller which act as a CPU, right, in a microprocessor which is used for the ALU, arithmetic and logical operations. So, most of the computers are developed based on the microprocessor. Most of the embedded systems are developed based on the microcontroller. So, the 8051 microcontroller having the 8-bit CPU, along with that it have more features which having the internal RAM and internal ROM. The internal RAM is 128 bytes and internal ROM is 4 kilobytes. So, based on the memory we can easily design the specific application. It have a timers, two 16-bit timer which are denoted with T0 and T1, which is used for counter as well as the timer purpose. It have a full duplex serial data communication. What it represents? A single mode which will be used for the transmission and also for receiving. So, these are the features of 8051, right. It is a 8-bit CPU with some supporting internal registers, having memory with timer and counters, serial data communication. So, generally the microcontroller which contains the program memory and data memory, along with that input and output ports in a single chip which is used to build a complete application. That is why we are preferring the microcontroller for any one of the specific application compared with the microprocessor. The microprocessor which have only the ALU, additionally we have to add the memory and ports. In microcontroller compared with that it have a facility, built-in facilities. The user needs to add suitable sensor and actuators. So, based on this concept only, in today's world we all are moving towards the Internet of Things. So, the Internet of Things also developed based on the microcontroller like Arduino board and Raspberry Pi. So, now we will discuss about the architecture of 8051. 8051 is a 8-bit microcontroller. What it states? It having 8 data lines. Okay. Any one of the processor having number of address lines and data lines. So, this also having a 8 data lines and 16 address lines. For parallel communications and also for input and output operations, it have a 4 ports which are named as port 0, port 1, port 2 and port 3. Okay. So, 4 ports along with the 16 address line and data lines. It also having the special function registers, some supporting registers. Okay. Now, see the architecture, you will get the clear idea. So, this is the architecture of 8051 which having 4 ports. This is a port 0 which have 8 lines, each port having the 8 lines. Port 0 have 8 lines which are used as a input output lines. Port 2 having the 8 lines which also bidirectional. This is a port 1 and port 3. All ports are bidirectional ports. Okay. The port 0 not only used for the input and output lines, it also multiplex the address and data lines. So, the lower address line what it states A0 to A7, actually it has a 16 address lines. So, the first 8 address lines will be multiplexed with the first 8 data lines. So, AD0 to AD7 along with input output lines available on the port 0. In port 1 it have a 8 bidirectional signals, it used only for the input and output lines. This is a port 2, the port 2 having the 8 bidirectional lines which are used for the input output, along with the remaining address lines which are A8 to A15 higher address will be multiplexed with this. So, here this port 0 and port 2 is used to generate the 16-bit address lines. So, actually the multiplexed address and data lines are demultiplexed by using the ALE signal. ALE is address latch enable, which is used to demultiplex the multiplexed address and data lines. Then this one is the port 3, which is having 8 bits of bidirectional lines. So, this ports also call it as multifunction ports, because this port not only used for the input and output, it also used for the timer, serial communication, interrupt and the normal read bar write bar operations. Okay, that kind of 8 signals. For the serial communication, we have a TXT RXT line. TXT is used for transmitting the data, RXT for receiving the data. So, 2 separate lines will be available, which are P3.0 and P3.1. Remaining 2 signals which are interrupt signal INT0 and INT1, which are external interrupts. So, any response raised from the external devices, the microcontroller immediately suspend its current work and switch over to the specified task for completing the application. That is why we are using the 2 external interrupt signals. Along with that, we have a 2 timers T0 and T1, both are 16-bit timers. Okay. So, we can initialize any kind of values for counting purpose, and also it used for generating the waveforms. In port 3, the last 2 signals which are read bar write bar used for the read and write operations like other processor. So, these are the 4 ports, totally 32 IO signals are available in 8051 to perform the input output operations. So, not only for the input output operations, it also used to generate the address lines, data lines, because for any kind of interfacing, the address line is used to locate the specification which have the unidirectional line. The data lines which are bidirectional used for reading the data and also for writing, or you can say we are sending the data and also for receiving the data. So, the multiplexed address and data lines are demultiplexed based on the ALE signals. Okay. Then it having the internal RAM and ROM, which for storing the data. RAM is called it as a data memory and ROM is called it as a program memory or code memory. Okay, this is a ALU structure, right. In the ALU structure, what is ALU? ALU is arithmetic logic unit. Okay. So, here all kind of arithmetic operations like addition, subtraction, multiplication and divisions operations along with the logical operations which are and, or, not and exclusive, everything will be performed in this 8-bit ALU. So, for that, for all kind of operations we need 2 data. So, 2 registers, temporary register 1 and 2 is initialized, right. So, after getting the 2 data, this arithmetic unit will perform the given task. Okay. Then the result will be passed to the system bus. The system bus is nothing but the combination of address bus, data bus and also the control bus. So, for arithmetic operation, one of the data should be loaded in the accumulator. Okay. In 8051, it has 2 registers, accumulator and B register. Accumulator is playing a very important role, because for all kind of arithmetic and logical operations, one of the data should be loaded in the accumulator, another data loaded in any one of the register, right. Then after performing the operation, the result is stored in the accumulator. That is a special one in 8051, and when the controller wants to communicate with the external devices, via the accumulator only it can communicate. And when the controller access the memory, data from the memory, either from the internal memory or from the external memory, via the accumulator only it can perform. That is why the accumulator is called as a special function register, or it also one of the special register to perform the arithmetic and logical operations. Another 8-bit register is B register usage. Along with that, for multiplication and division, the data should be loaded in the B register. In case of multiplication, multiplicand is loaded in accumulator, multiplier is loaded in the B register. So, after performing the multiplication, the result is stored in the accumulator and B register if any higher byte is occurred or any carry is occurred. During the division, the dividend is loaded in the accumulator, the divisor is loaded in the B register. So, for multiplication and division, B register should be used. Then after arithmetic operations, the result will be stored in the PSW. What is PSW means? Program status word. It will give the status of the arithmetic and logical operations. It is a 8-bit word, we will discuss later. Then the timing and control signal, which is having the 4 kind of signals. Here the ALE, which is used for demultiplex address and data lines, which is arithmetic logic unit, right. PSEN is program store enable, which is used to read the data from the code memory. Then EA is a active low signal, the bar represents active low signal, which is external enable, external access. When the signal is low means it represents the controller can access the data from the external memory. When the signal is tied with a high means only it will access with the internal memory. Then this is the reset signal, which is used to clear the internal register values. Then here it has the oscillator, which is used to generate the frequency. By using the 2 crystals along with the capacitor, it will generate the frequencies. It can generate the maximum of frequency from 1 megahertz to 60 megahertz. So, based on that, the controller will take the signal and will operate. Okay. So, 2 8-bit register A and B, and also it have the 2 16-bit register. One is program counter, another one is a data pointer. So, program counter is playing a vital role in the 8051 because it is one of the 16-bit pointer which is automatically increase its address by 1 during the execution time, which is used for fetching and decoding, right. So, it will maintain the sequence of the program execution. Data pointer is a 16-bit pointer which is used to access with the memory, and also it is used to initialize the memory location during the programming. It can be used as 2 8-bits, either lower register or higher register, based on that DPL or DPH. Then we have a stack pointer. Stack pointer is one of the temporary memory, it is a RAM, we can read and write with the principle of last in first out by using the push and pop instructions, we will discuss later. These are the special function registers, which are power control, serial control, T mode is timer mode, TCON is timer control, then T2 timer 2 control, then the T0 T1 can be used as either 2 16-bit registers or it can be split it as a 2 8-bit. So, totally 4 8-bit registers. For T0 it will be divided as lower and higher, TL0 and TH0. For T1 it will be splitted as TL1 and TH1. So, based on your counter value you can initialize either 8-bit value or 16-bit values. This is for T2, okay. These are the not in 8051, it is a future one. Then SBUF, serial buffer, so where the data is stored during the serial communication. For interrupt it have a 2 special function registers which are interrupt enable and interrupt priority. The interrupt enable register is used to enable the particular interrupts. Totally we have a 5 different interrupts. Suppose more than one interrupt rising request at a time means automatically it will get a confusion where to provide the priority. So, here we have a interrupt priority register which will assign the priority, right. Based on the priority it will give the service for the request. So, generally in 8051 we have a 2 8-bit registers which are A and B register, right. It have a register bank. The register bank it have a 4 banks which are denoted with RB0, RB1, RB2 and RB3. Okay. Each bank having 8 registers, that registers are denoted with R0, R1, R2. 8 registers are 8-bit registers. So, totally based on the bank we have a 32 8-bit registers which are used for the general purpose. For initializing the data, we can store the data like that. Then we have a 8-bit stack pointer, 8-bit program status word and 7 special function registers. program counter. Program counter is a memory pointer, it automatically increases its address during the fetching of each instruction. That is why this is used to maintain the execution of the sequence of program. Once we are pressing the reset button, the program counter will be initialized with a 00, that is the program counter value is cleared. The next one is the 16-bit register is a data pointer. This data pointer can be used as a 2 8-bit register also. For higher byte we are using the DPH, for lower byte we are using the DPL. It is used to access the memory either from the internal memory or from the external memory. The program status word, it is a status register, it will give the status of arithmetic and logical operations, right. So, we cannot write anything in this register. Based on the operation, it will be affect the corresponding bit positions. We can understand what operation is performed or what happened during the operation. Okay. So, out of 8 bits, 7 bits are used. The first B0 bit is P, which is a parity. Parity means which is used for the checking, error checking, right. It will be either odd parity or even parity. If it is 1 means it is name it as a even parity, if it is 0 means it is a odd parity. Third bit is OV, which is overflow flag. Overflow means it exceeding the size. Actually we are adding the two numbers which are having the 8 bit, right. 8 bit plus 8 bit, we are expecting the result also in 8 bit. Suppose the result is in the 9th bit, means automatically this bit position become 1, which indicates it extending the size, right. The overflow is occur. The next 2 bit positions which are RS1 and RS0, which is used to select the register bank. Already we have discussed 4 register banks we have, which are denoted with B0, B1, B2, B3. So, which bank we want to use will be based on these 2 bit positions. If RS0 and RS1 is 00, then bank 0 will be selected. If it is 01 means bank 1 will be selected, 10 means bank 2, and if both bits are 1, then bank 3 will be selected. Okay. In each bank we have a 8 registers which are denoted with R0 to R7 for all 4 banks. F0, F0 is a user defined flag. AC, that is it is not used, it will be used for the future purpose. AC is a auxiliary carry which is used for the BCD operation. In the BCD, during the BCD operation, what it indicates whether the number is exceeding the 9 or not. Okay. When the auxiliary bit is 1 means it exceeding the size, and also what it indicates the 4th bit to 5th bit, right. BCD mostly represented with the 4 bit representation. So, during the addition of 2 4 bits, if the carry is occur, then the 4th bit will be moved to the 5th bit, the carry over to the 5th bit, that is why it is called it as auxiliary carry, it is mostly occurred in the BCD operation. Then CY is a carry flag. When the bit position is 1 means during the previous arithmetic operation the carry is occur, right. If it is 0 means there is no carry. The same bit position also used for the subtraction. During the subtraction, when the carry flag is 1 means it represents the borrow is occur. If it is 0 means there is no borrow. Okay. So, based on the addition it will be called it as carry, during the subtraction it will be called it as a borrow block. Stack pointer is one of the 8 bit memory, right. Here we are storing the value from the top of the stack. What it represents? We are initializing the maximum memory, then we are storing the data. Okay. The stack is operated with the principle of last in first out, that is which one you put it last, that how to take it as a first. So, for here the read and write both operations will be performed. For read operation we are using the pop instruction, for write operations we are using the push. So, the push is used to store the data into the stack. So, during this operation what will happen, the stack pointer first increased, then it will store the data. This is the concept. How we are storing the data in the stack pointer means the stack pointer address first increased, then we are writing the content. the POP pop, which is used to retrieve the data from the stack, which is used to read the data already stored one. Okay. So, during the read operation, it retrieve the data first, then the stack pointer is decreased by 1. First it will take the data, then the address will be decreased by 1. This is the principle of pop. Okay. Push, what it will do, first increase the address, then write the data. The pop will take the data, then the address will be decreased by 1. That is the difference between the push and pop. So, the stack pointer, which is used to maintain the program execution. Okay. When we are using the jump instructions, the program counter will be loaded with a new address where to switch over. So, during that time the current address will be loaded into the stack pointer, then the program counter will execute the subprogram. After that, after reading the return instruction, it will be returned back to the proper place by pop the data from the stack pointer. So, during the jump instructions, the stack pointer also playing a role to maintain the sequence of program execution. Here we are using the crystal to generate the internal frequency for 8051, right. So, here it will generate maximum of 1 to 16 megahertz. Here how the clock pulses are arranged means, here 2 pulses will be represented as a state. So, a single pulse or single machine cycle consists of the 6 states, each state having the 2 pulses. The pulse represents a period, which is one on and off period, right. So, totally 12 pulses are used for the one machine cycles. During this time the ALE signal is twice it goes to the high, or for every 2 states it goes to high to demultiplex the address and data lines. That is why here we are calculating the frequency, that is the number of cycles into 12D divided by the whatever the frequency is generated from 1 to 6 megahertz, that is considered as a time period. In today's session we have discussed about the 8051 microcontroller. This controller is the basic for embedded system, right. It is a 8-bit microcontroller which represents it having 8-bit data lines, right. It have a 2 8-bit registers and 32 registers internally with the register bank along with 2 16-bit registers, and especially it have a 7 special function registers which are supporting for the peripheral communications. Okay. So, before starting any design from the 8051, we have to know these kind of internal structures along with the internal registers, then only we can start the design easily. Thank you.